Hello, my name is Hemmo Mätränen, and welcome along to another MagiCAD webinar. This is the third and last webinar in series of three webinars, two of which were held yesterday and on Tuesday. And today we're going to look at our products and the technical data in them. Feel free to type in questions in the questions box, and I'll try and answer to those at the end of this session. We'll reserve a few minutes for that. And if I'm not able to do that, I may even get back to you by email if needed. Yes, let's go on and jump into today's topic. Let me begin by showing you first our MagiCAD Cloud website. In MagiCAD.com, there is a link to our cloud library where you can browse our BIM objects. And our licensed MagiCAD users have the full access to our library, but also pure Revit users have a restricted access to these products from around 280 different manufacturers. And here you can browse the products by manufacturer, for example, and see the technical data in these products and download RFA if that is available. And you can also see the different variants and their data. Let's come back to this cloud a bit later on. Yes, so how do these products then behave in our project? Let us begin by opening dataset, the project file that contains all the information a MagiCAD project needs. Supplier devices here, for example, if I open one of these and its dataset properties, we can see here the general information like user code and descriptions and general parameters, plus the localized symbol databases like Airflow, arrows databases that we update continuously, both for simple Airflow arrows and these product symbols. And if companies have their own shared parameter files, they can use them, access that through the dataset, and use their own shared parameters from that file. And users can also give the default values for them, select if it's going to be instance or type parameter, and select the parameter group also under which it's going to be placed. So these, their own shared parameters are available then when the user inserts the products to their project. And updating the update to project also works if the product happens to already exist in the project itself. Yeah, so let's go on and install one of these products. Install product selection dialog allows us to browse through the family types, different sizes. And on the right-hand side, we have the performance diagram, pressure losses. According to the flow, we can see velocity, pressure drop, and adjustment value. And you can see that the operational point moves along the diagram. OK installs the product, and the installation dialog opens up for us. We can select the system, Airflow arrows, which we want to use, and install the device at the end of the duct, for example. For now, we only have this amount of supply airflow in the tag since we don't have run calculations yet. And we can always go to our MagiCAD properties to see the operational point that we chose and see the diagram and general information. And in addition to calculation related information, we can also, for example, if we need to lift a branch slightly, we can do that and still keep the air diffuser where it was. So lifting a branch slightly, adjust terminal color. So if the real life product has the ability of adjusting the color length, we can do that in the MagiCAD as well. Okay, you can see that the diffuser stays where it was, and if I undo, you can see the difference. So the diffuser most likely has been installed according to a ceiling, for example. Diffuser rotation angle can be also changed according to ceiling panel orientation. So there is lots of different kind of data in the products. Extended flow analysis then allows us to experiment more with these products. We have an air handling unit in our system. Balancing to fan pressure is therefore chosen. Okay. And here you can see on the right-hand side, pay attention to the QV column. At the moment, there is the first value is 84. That's the damper. So that tells us in percent it's the flow rate from a design flow right there. That's the damper there. So it at the moment is not getting enough air. So what we can do in this report directly is we can go to a single object and adjust the damper position, for example. Here, let's slightly open the damper position and click on OK and see what happens. Update simulation, updates the calculation, and you can see that the QV column there changes for all the devices because now they are getting more air and it's getting closer to 100. And we are getting closer to an optimal situation. Air handling unit fan speed setting can be also adjusted. Update simulation, now the QV column has even bigger values because the airflow rate is bigger. So this is how we can go on and actually use the dynamic data within the products. Let's update it back to the original situation. A lot of information down the whole duct network, and updating to the model updates the tags as well. As you can see, the values get updated, and also the parameters, product parameters on the left-hand side get the updated values, so we can browse them and view them. And again, the product properties, operational point, we can see where it is, and also make notes to the sound power level data at the bottom. That is also calculated, and manufacturer provided data that as well. That MagiCAD then calculates when balancing. Let's jump into piping. Install a fan coil unit here. There are systems to begin with. The system temperature difference coming from the systems and the input power data. You can see when typing in a new desired power input, the operational point moves along the diagram there as well. And the according to the fluid characteristics, we get the pressure drop and calculated flow already in this phase. Okay, so we get the idea about our performance in the network. Let's install the fan coil unit and see the install dialog. We can override the system temperature difference if we want, type in a new power if needed in this point. And also when we want to determine the whole volume of the network, we can type in that value also for the device. So it helps us determine that. Tag on placement and apply. Let's move the tag slightly away. And let's finalize the installation by connecting the pipes. So in addition to devices, let's go on and install a valve, also a differential pressure valve in this case, And now I'm referring to the differential pressure between supply and return. In the dialog, we can determine the value, let's say 8 kilopascals in this case, and install the valve in the return system. So apply accepts the installation. And on the supply side, you can see there is another valve. Also, we need a counterpart for the differential pressure valve, which is this one here, the measuring valve. And this parameter here is measuring valve. Make sure that these two valves are in connection with each other. They communicate, thus making sure that the differential pressure between supply and return is always set to the correct level. Running a balancing lets us see the report and the results. So here, first of supply, the total pressure 15.08, and the adjustment value and the operational point for the valve here. So we with this differential pressure valve, and here is the return, and you can see the adjustment value 8 kilopascals that we typed in, and the pressure loss. So before this valve, 5.08 kilopascals is the total pressure. So when updating this calculation, you can see that the differential pressure between the supply and return is the set 8 kilopascals. So that total pressure is thus reserved for the pump. So we can make sure that the pressure conditions with this branch is now set correctly. And you can see the updated tags as well. And this takes us to the fact that we have under the umbrella of zone valves, like this one here, we have a regular balancing valve before the fan coil unit, and the differential pressure valve that we just installed. So we have different kinds of valves under the same zone valve category. And if we go on to the domestic water side, we have here a constant pressure valve that helps us to determine a suitable pressure level for our domestic water systems. For example, if the let's say 150 pascals here. So this the situation after the valve, the outlet pressure is determined to be now 150. And if we run the domestic water balancing, we can here set the feed point pressure. So, okay, and the balancing report now shows the feed point pressure of 300 pascals and the situation for our pressure reducing valve of 150 right there. So we can make sure that the pressure conditions are correct in our network. And it helps us keep track on what happens in our network. So what happens then if we have a valve and we need a new size, for example, a new variant, but we don't have it in our database? What we can then do, since this is a generic valve we are talking about, we can go to the dataset, open the dataset properties, and browse through its available sizes. You can see the 50 there is the biggest one available at the moment. But if we need more of those, we can access through dataset the MagiCAD Create right there, the tool that allows us to modify information within the valve family. So we can take an existing one, this 50, for example. We can take a copy of it and duplicate that size, give it a new name according to the size that we want, let's say 60. Give it a new name, and also the save it and give it a new geometry, pipe diameter also accordingly, 60 right there. Save it and insert it insert it back to dataset. So now we have available for us a new size if that is needed, 60 right there. And we can select it and continue our designing. We can also go access MagiCAD directly through these dataset properties and filter valves according to a size, for example, and insert real manufacturer products and see their technical data right there. And variants and insert it to the dataset. So constructing the dataset, it is pretty straightforward thing. MagiCAD Create in general allows us to modify products under each category that we have in MagiCAD. Like for example, here in this case, a ventilation air supplier device. We can take always a new product from our product browser, a generic one, see if there is a product that we close enough product that we could use, and take one variant and view its technical data, and for example here make adjustment value modifications, type in new pressure losses, and see how the diagrams get updated, as well as the sound specific data for adjustment values, airflow rates, and pressure losses. We can type in new sound generation data. And when we are happy with our modification, then we can save it and start using it in our project. So we have created a new valve variant. What we can do if we want to use it right away, we can, for example, find with the find and replace tool, select the old one directly in the project, and through search through the dataset, the new one that we just created, the new size, and replace it in the project. Applying accepts the replacing, and there it is. We can check that it's okay in properties. That is the new one with correct data within it. Rich data content means also information exchange, like in this MC is linked in schematics, tells us that I've linked this 3D model with the schematics symbol that you can see on the right hand side, this one here, and I've also linked the valve with the real 3D model. And here in schematics tool, synchronizing parameters means that we can push information from the 3D model to the schematic symbols. Like here we can see MC cooling power, user code, adjustment value, and piping flow. The same parametric information gets updated for the schematic symbols and the tags right there. So we can make sure that if our schematic drawings need to have similar data as the 3D model, we can do that with our schematics tool and update parameters by pushing information, exchanging information. And also pipes and duct segments, like you can see here the green highlight color, they contain not only calculation related data, but the always when we update the calculation, you can see the changing highlight color, which is the index run. In this case, the index run information is stored in this MC index root information, and we can highlight with Revit filters. We can highlight, for example, an index run in a duct network if we want. Also, when it comes to pipes, a modeling requires a lot of elevation parameters. For example, like in this case, we have both with insulation and without insulation, the elevation information, parametric information that we can use in tags, and all those parameters are available to us when we want to see that information and use it. So at the end, we go back to the cloud. So all the pure Revit users, they can they can download our MagiCAD Cloud Connect, and it appears here as its own tab here. They can access the products through the search product icon and browse through these different object categories, ventilation, supplier air device, and use, for example, a ventilation operation point like flow 50, minimum pressure drop 100 and 150, and updating the search then narrows down the available products. Like you can see here, the product family is 3,600. Updating that according to the operational point narrows down slightly our available products here. And like I showed, you can always go and see the technical data and insert it right directly to your project. So let's see, is there any questions that you like to ask? Let's see, yes, I'm a MagiCAD user in Canada. I wonder if there is a Canadian or American manufacturers in the MagiCAD Cloud. I can't recall now by heart. There might not be that many. One reason could be that we don't, well, so far we don't support the Imperial system. So we could be that we cannot, that we don't have that many North American manufacturers in our library at the moment. But we are keen on expanding our product manufacturer, our selection of manufacturers all the time. So let's see, maybe in the future we will have North American manufacturers as well. But maybe I can check that and get back to you by email so that I can give you a certain answer. All right, that's about it for today. If no more questions doesn't seem to be there in the question box, so I will thank you and see you next time.